So number one, what are our key points to decide what number one is? Very low melting point, probably low density, and crumbly are secondary but quite important. So what did we call number one? Molecular, yeah. So the low melting point is the key one there. Okay, number two. Oh, it's a tricky one. So what are our key ideas in this one? Does not dissolve in water. So what is that going to kind of eliminate? Ionic. Yeah, that'll eliminate ionic.
And it doesn't conduct electricity.
It doesn't conduct electricity, so it can't be metallic.
And it's very hard.
Very hard. It is a diamond. Well done. Hard, colourless crystals. Okay, number three. So what have we got? What are our key points here?
It's hard, very high melting.
Yeah, high melting point. Dissolves in water. Brittle. Good, Shayla.
Conducts electricity.
What conducts electricity? The solution conducts. So what's that going to be? Ionic. Good, well done. Number four, we've got something forming some kind of silver crystals that do not dissolve. Tell me about the melting point. High. Good, so what is it most likely to be? Graphite's a great conductor of electricity. Would a molecular have a high melting point? No. It's going to be a covalent network. Something like silica, yeah. So it's a non-graphite. We've already done diamond. So silica is a good answer if you got that. So there's two specific answers. Right, last one. What do we reckon this one is? Yeah, it's a metal. What doesn't seem to fit with a metal? Soft. We don't naturally link soft things with metals, but there are some very soft metals. It's aluminium. It's not graphite. It's a metal. Yeah, very malleable. Yeah. Okay. Yes, magnesium is a soft metal. That's true. Okay. All right, girls. Let's get our notes books out, please. No, I haven't given you, I haven't marked your stuff, no. Okay, so I want you on in a new section, and we're going to take some reasonably extensive notes today, just to kind of remind us about the key ideas of the things that we just went through. So, I'm going to call this one Weakened to Molecular Forces. Yeah, so we've finished electron configurations, we've finished Lewis structures and polarity, we've finished periodic trends. So this is, we are ticking them off. Okay, so what we're going to do first, come on girls. Okay, so what we're going to do first is we're going to just make a little decision tree about stepping through when we need to identify a substance and what forces are holding it together. So the first thing I'm going to get you to do is go right back to year 9 and using a circle to indicate a particle, I want you to draw me across your page a solid, a liquid, and a gas. It's quite important, okay? So that's what I want you to use as your particle, a little round thing. It's going to say a round circle, but that's redundant. Okay, so draw me a solid, draw me a liquid, draw me a gas. Year 9 science. Go, make your year 9 teacher proud.
You were my year 9.
I know, make me proud. Mari. Alana, make your year 9 teacher proud.
Lucy.
Yeah, I see, I already knew you two. Yes, Taylor.
We're exposing everyone.
Yep.
Can you take my ruler back, please, eventually? I'm still drawing my containers.
Well, solid can be. Solid doesn't need a container.
It does. Everything needs a container. It's just rude not to.
Hi. Yes. I'm videoing this whole lesson today.
But they can't see you.
Yeah. They'll see me when I'm here. Yeah.
So you're going to teach all of
I'm just giving it a try. Yesterday at lunchtime, Mari and Tiana helped me learn how to make a YouTube channel and post a video to it. They are already my first 2 subscribers. If anyone else wants to...
I subscribe.
Okay, have you?
I think so.
Okay.
I didn't know it existed.
No, it didn't until yesterday. Yeah. So,
I laughed at your always videos.
yeah, my first video was very random. I wouldn't watch it. And I'll have to truncate this one, I think. But I'm just giving it a whirl. Oh, don't. Yeah, I will learn how
But
to
if
do
you
that.
get really famous and then you make like lots of money,
I'm not going to get really
you can
famous.
like hang out with the ace fans.
They're not actually. I don't even know what that means.
Yeah, these famous people think
Yeah. But I did today think very carefully about what I was going to wear, and I am paying homage today to some strong women in the world, in our little world. Who am I paying homage to with my green?
Sunflowers?
No, come on, green. Come on, Jane Batten, thank you. Who-
Yeah,
Who am I?
Catherine
Thank
Mansfield.
you, Catherine Mansfield and Jean Batten, the 2 women that lead up our houses. So well done. Not my house, but that's okay. And I would also like to, while we're on the subject of women and you're just doing that, just say I just give my little love heart to Big T. Who's Big T? No, I'm not. I'm Little T. Who's Big T? So what, Miss Harvey?
Tara.
Yep, Big T is Miss Kanji, because I think she's doing a good job leading us at the moment. And even bigger hearts to who?
Jacinda.
Yeah, Jacinda.
I'm like,
And who's Jacinda listening to?
She's listening to what's that nerdy girl that
Who's Jacinda listening to?
Nano girl.
No, not Nano Girl.
Donald Trump.
Come on. Thank you, Susie
I
Wiles.
thought Nano girl was a good guess.
Yeah, Nano Girl's a good guess, but she's not as good as Susie in this case. The pink-haired lady who's actually a microbiologist.
I thought that was.
Yeah, Nano Girl is good. I'm not taking anything away from
I'm going to tell Nano
Susie Wiles has pink hair. No, I do like her.
I'm telling on you.
Yeah. So there you go. Look at all these women doing great things, including us. Okay, let's go. Solid.
Wait, can you be proud to me?
That's good. Okay, so in your diagrams, girls, come on. In your diagrams, you should have your sort of. This is going to be really important that you understand these really well because there's some big questions around this. So the particles should all be the same size, it's the same substance. So you shouldn't have changed the size of your particles. Solids, regularly arranged and tightly packed. Liquids, still lots of bonds between particles, but some that do not have bonds, and no regular arrangement, right? Very, very random in a liquid. And gas, there is no bonded particles in gases. They are all separate. Okay, so we just looked at some different types of solids, the 4 that we learnt last year. And really key thing to remember is that the difference between these solids is what are these particles and what holds them together. Alright, so a metallic substance has different particles and different forces holding them, or bonds holding them together, than a molecular, than an ionic, etc., etc. So let's just do that. Let's just write that below.
I like your shoes.
Yeah.
Who are they representing?
They're representing the fact that I just bought them off Trade Me. It's the 3rd day in a row that I've worn them because they're my favourites at the moment.
Touching my toes again.
That's the only reason why I wear sandals.
Okay, so each substance has different particles and different forces holding the particles together, which gives each substance its properties.
Do you want me to draw a circle between the sentences?
You don't have to, you can choose.
It was good. You're not going to be doing that question later.
No.
Oh, if you do it live, you can.
Yeah, well, I'll be able to do it live soon. I can't go live today.
Do you go live when she's been on it for 24 hours?
Yes, when I've been subscribed for 24 hours, I'm allowed to go live. They told me that this morning. So I might try period 5 to go live.
Who told you
Try
that?
that. No, haven't told anyone.
No, I said who told you that?
Oh, the YouTube people.
Thank you.
When I tried to go live, they said you can't do it until 24 hours after you've
Okay.
done your thingy-majingy. Yeah, whatever it is. Yeah. Okay. Right, so now we're going to do a great big decision tree. So I'm just going to give you a couple more seconds to get that down. Decision trees, well, it is a kind of a decision tree. They're quite good. Because what actually happens is 99 times out of 100, our questions this year will be about molecular. But every now and then, they slip in a level 2 one just to see if you're awake. So I'm going to start with level 2.
And we're not awake when we get bad mark.
That's right, you'll get a really bad mark.
My decision tree is not one of it.
No.
I thought you like decision tree. What's that?
No.
Oh, is this an untitled?
What's underneath that, yeah.
I love how decision tree on how to decide.
Yeah, that's kind of redundant, isn't it? Yeah. You can take that out.
That's necessary.
Yeah. Yeah, quite. Yeah.
How much space do we need? Lots of space or little space?
A reasonable amount. I'm making this up off the top of my head. It's a lot though. Like it's a lot of.
Is it like going to be bullet pointed or like a tree?
No, it's not actually going to be a tree. You can actually do these properly, and I've done it a million different ways, and every time I do it, it's not quite how I want it. So I'm going to do it. There's actually software you can use to make a decision tree, which is really quick and easy, but I don't want to muck around with that at the moment. I just want to make sure we're getting through stuff. Yeah, you can do it. That's a good thing to do in your own time to reframe and go over and put things into a different way. Okay, so we're going to ask ourselves a question, then we're going to go yes, no kind of thing. So we're going to start off with the level 2.
Is that nice?
Yeah.
Oh.
Right, so our first thing we need to look at, we'll be presented with a formula of some description. And what I need to know is, when you look at that formula, does it have any metal elements in it? Or is it carbon or silicon base only? Okay? Now, if we have a no, we are going to go to the next question.
If we have a yes, what is it?
Then I'm going to put that underneath. Yeah. Go to 2 or 3. Let me just think. Let's go to 3. Yeah. Oh, look at this. It's like those things we learnt in year 9 again.
I never did this.
Didn't you?
I didn't do this.
So you do the
No, you would have all done it.
I always die.
It was in the end of year exam, this stuff. You had to follow the trees and go to yes, no's.
No.
No.
Yes.
Yeah.
Yeah.
I've never done one thing that
No, you have.
Talking to the, you guys are talking to the
In a department.
You have, because every single year 9 did the exam at the end of the year, unless you were sick. And the exam at the end of the year has one of these in it. You didn't have to make one, but you had to use it. Like there was little animals, and it said, do they have 6 legs or 5
yes, I remember
legs?
that. That was cool.
Yes.
I did that in year 10 as well.
No, well, it's just for science in year 9.
But you did that in year 10 as well.
I thought you did it.
No, it was year 9.
Because I remember doing one for Senior though. Yeah, we did last year.
Oh, we did it last year, I mean.
Why are you highlighting it? We got a practical one, so it's not was that necessary? No. Next year,
Right, so that's our first decision made. If there were metal elements or carbon silicon, then we very, very quickly need to just say, okay, that's a level 2 one. If it's a metal and a non-metal, e.g. NaCl, right, in the formula, that's ionic. If it's a metal only, e.g. Fe, that's metallic. And if it's carbon or silicon, which is like diamond, graphite, etc., then that's covalent network. Unlikely, because they've tested you extensively on that already, but it's good to just remember. What's that? Number 2.
what are these technicalities?
It's the end of your line, number 2. Yeah, because you go till you get to the end, and then you use that. Okay, so is everyone happy up to there? So we've got a very quick remembering of how to identify those things, and you've had a really quick look at those properties, which you might need to know, but maybe not. Probably not. So let's go to number 3. So number 3, we must have non-metals only, which is molecular. And then we have to keep going, because now we're into the new stuff. So up to this point, there is nothing new. It's just revising things that we already knew, right? Everyone happy with that?
Static.
Static.
That was
I'm going to rub this out.
Oh, it's still on the decision. No.
What, yeah, are you not up to number 3?
I'm up to metal only. I'm not. Are we still under the decision tree?
Yep, we're still going. Because we've got a few more decisions to make yet.
Oh my god, how many? 10?
No, only about 3.
Oh, that's all. So this is all. Oh.
No, 3 more. No, this next bit's the new bit. It's not too bad, I don't think. Anna, have you done number 2?
You guys should really take photos and do it at home.
You right, Eve? I know. I need to update my team. Okay. I'm going to rub number 2 off now, and we're going to carry on with number 3. Okay, so girls, this is the new stuff, so you need to focus up a bit here. So the first question you need to ask yourself under number 3 is there an F, O or N covalently bonded to a hydrogen? Now, where have we seen F, O or N before? Right, so the first 3 in Fonkel. So what is F, O and N going to be? The 3 most electronegative elements, F, O and N. So that's our first question here. Blah, 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 blah. Right, is there an F, O or N covalently bonded to an H? That's fine, you can absolutely do that. I encourage you to do it in a way that makes sense to you, or redo it later. Okay, so is there an F, O or N covalently bonded to an H? And this is our yes. Right, so if we say yes, if there is an F or an O or an N covalently bonded to a hydrogen, then our weak intermolecular forces are called hydrogen bonds. Who's heard of hydrogen bonds before? I know you've seen them somewhere, some of you. What other subject has got hydrogen bonds in them? Bio. Where are hydrogen bonds found in bio? Right, in your DNA and also in your proteins. And if we didn't have hydrogen bonds, we'd be dead because they hold you together and allow you to be alive. They are very, very important. Okay? Have you ever seen a gecko running up a wall?
Yeah.
Right. So they don't actually have sticky feet, but they are forming these little hydrogen bonds. Yeah, possibly something like that. They're forming little weak intermolecular forces, and we're going to talk about why they can do that at some other stage. Yeah, I'm going to come back and fill that in, but it's just going to be 2 letters, 2 letters, so you don't need. You can just leave a little gap there. Okay, so we know that if there's a yes there, we've got hydrogen bonds. But if there's a no, then we ask ourselves another question. Okay, so our second question. So if it was a no to the hydrogen bonds, then we ask ourselves, is the molecule polar? Right, we know how to establish if a molecule is polar or not. And if it is polar, then we can say that our weak intermolecular forces are called permanent dipole, or PD-PD. I'm going to explain what all these are in due course, okay? So we're just going to get this down first. And then 6 is our last one. I'm just going to put, is anyone up to hear you? You guys are so quick. I'm just going to put an also and in there.
Is the and onto the permanent dipole?
Yeah, onto the permanent dipoles.
So does it go after, like, does it end up or after?
In here.
After it will be.
So our last one is if we said no to hydrogen bonding, we said no to being polar. So we've got a molecular thing which is non-polar at this stage. Then its WIF are called temporary dipole, or TD, and that's all they have. We've got quite a bit more learning to do with this, but I just want to stop and just think about what we've just learned first. Okay, so get that down to 6, 8.
Why is it double?
I will teach you that, but it is important that it is.
Look, I made a decision tree.
Beautiful.
Oh,
Okay. Alright, so just cut these in half, girls, when I hand it out when you're ready to go, and make sure you've got one each. And then we're just going to practice having a look at what this all means. diagram. So just when everyone's finished, we'll just have a look at, at this kind of Venn diagram here. Okay, all right, so